Hi everyone, welcome to our third Excel tutorial. Today I'm going to quickly demonstrate how to do a multiple regression analysis in Excel. You'll use a similar procedure if you wanted to do a simple linear regression with just one dependent and one independent variable. Our multiple regression will have one dependent variable and multiple independent variables. To start our regression analysis, we'll click our Data Analysis tab. We'll make sure that regression is highlighted. In our dialog box, we'll hit OK. What we'll do then is select the data that we want to use. So I'll delete these for now. So our Y range, that's our dependent variable. And we want our dependent variable to be price. So I'll select price. Click and hold all the way down until we select all of it. As you can see, there's a lot of data entries here and a lot of data. Our X range then is our independent variables, sort of our predictor variables is what we can also call them. For the regression I'm going to show, I'm going to use rooms, lot size, age, and area. For your own multiple regression, it might be a good idea to look at the data that is provided and see if there are any other important variables that you think might be better predictors of house price compared to the ones I'm using. You can make your own judgments about the different variables that are provided. And decide on if you think any are more important based on your own knowledge and judgment of house prices in Australia. But for now, let's just use rooms to area, so C1 to F1. What I'll do is I'll start by selecting rooms, click and hold, and again follow this all the way down to cell 121. So we'll do that. And I'll just scroll back up now. So because we have selected our labels in our first row, I'm going to make sure that our labels tick box is ticked. Ticking our labels box will tell Excel to take our first row of cells out of its regression equation. Doing so means that the actual regression equation that Excel will start with starts at our first row of numbers, which is what we want. We don't want, and Excel can't, you can't do a regression equation if you had your sort of titles included. It wouldn't work. We want to tell Excel to output our statistics in a new worksheet. So we'll have this box ticked. And we also want it to see our residuals, our residual plots, and our normal probability plot. We'll just double check that our input Y and input X ranges are what we want it to be. So that's B1 to B121, that's correct, and C1 to F121, that's also correct. So we'll hit OK. Excel will take a second, do its analysis, and open you up into a new worksheet. So I'm just going to drag these across first and zoom in so we can have a look at our summary output. Let's open some of these up a bit wider so that we can read our outputs. Cool. So the first outputs we'll look at will be our regression statistics. So mainly we want to look at R squared. So we can see our R squared here, and its value is 0.45. So that's not great as a regression statistic. That means to interpret our R squared means that only about 45% of our model can explain the dependent variable's variance, which isn't great. We're looking for this number to be as close to 1 as possible, essentially. So with 4 variables only explaining 4 to 45%, that's not great. Our ANOVA table is our next table we can look at. The most important statistic here is the significant F. This is essentially just a p-value based on the F value, more or less. It's a p-value for the F test of overall significance. So this is the overall significance of our model. So Excel, once the values get very small, puts this value into scientific notation. So ours is 3.03001 e to the 14. Essentially what this means is that because our value is e to the 14, we need to move our decimal place 14 places to the left. So it's a very, very small number. So a significant overall model. Sort of looking more deeply into it, we have an F's of our F test resulted in a score of 23. That's not huge. So that's probably a bit smaller than what we'd like our F score to actually look like, but still probably fine. Finally, we'll look at our coefficients table. This is one of the more important tables to look at in our regression statistics. So we'll start with our coefficients table. When we're writing our multiple regression equation or regression equation in general, we'll use our coefficients and fill these in for sort of B0, B1, B2, B3 as we go on. So our intercept will be B0, and then we'll have rooms of B1, lot size of B2. When we write our multiple regression equation, we can just plug these values in as B0, B1, B2, etc. And sort of ignoring intercept because we don't particularly need to look at that. These values here, these are all positive values. As much as we can interpret from this is essentially that all of our independent variables that we included in our regression analysis all increase house price by some amount. If they were negative, they would decrease house price by some amount, whatever that amount may be. So we know that these all increase house price, essentially. And rooms looks to do it by the most. Our other important value that we'll look at is our t-stat and then the t-stat's associated p-value. We'll focus on the p-value because it's essentially just a lot easier to interpret. If we were working with a p-value of 0.05, which is a sort of standard 5% significant value, essentially, we can look at the p-values for our independent variables and determine whether or which of these p-values are or are not significant. So if we're working with a p-value of 0.05, we want it to be smaller than that. So the first p-value we have is 0.08. That's bigger. That's no good. So we know that although rooms increases house price by a lot, in this multiple regression equation, it's non-significant. Our next independent variable is lot size in square meters. It doesn't increase house price by a lot, but it is a significant predictor. Again, e to the 6. So we're moving our decimal place 6 places to the left. So that's a very small p-value. So that's a significant sort of independent variable that explains our dependent variable. Our next one is 0.5, age. no good. And finally, we have area at 0.012. That's smaller than 0.05, so that's another good significant predictor in our model of house price. So as we can see, we had some statistically significant predictors of house price and some that were non-significant. From this regression model, what we might want to do then is go back and to our data set, take a look at what variables we have data for, and see if there are any that we think might be more significant than rooms and age to predict or explain the variance in house price. If we go back to our data set and we don't think that any of the other variables make sense to use in a regression equation based on our knowledge, understanding, judgment, or prior literature that we can find on explaining the variance of house price, then what we might do is say that the most parsimonious model based on the data we have only includes lot size and area within our regression model as two significant sort of predictors of the house price variance. What our multiple regression sort of coefficients and t-stat and associated p-values show us, though, is that although our overall model is significant, there are variables within our model that are not significant, which can be kind of confusing to get your head around. But again, it's the understanding that the ANOVA is a sort of analysis of our overall model fit, whereas this third table is a independent variable by independent variable analysis within the model fit. And the t-stat and associated p-value of that t-stat tells us whether that particular independent variable is significant within the model. So we'll highlight area and lot size and continue on with a model that only includes those two variables. So that was a pretty quick rundown on how to do and interpret a multiple regression analysis in Excel. Alongside this video, I'll put some links to some more in-depth sort of blog posts from the internet that help to explain how to do a regression analysis and how to interpret it, because it's sometimes easier to read and go to where you want rather than look at it in a video form. But in general, that's how you do and sort of analyze the Excel outputs for a multiple regression equation. Again, from here, try your own. Don't just put in all the variables or whichever random variables you think. Use your critical thinking and judgment skills and or an understanding of how house prices might be predicted, and make some judgments about the variables we have and see if there's any that you think would be more significant than the ones I've used. And you'll need to become efficient at doing these, both for your assessments and in the quiz as well. So make sure you do have some practice doing and interpreting regression in Excel quite quickly. and I'll see you all next time.